Now let's look at limits at infinity. When I say something like the limit as x approaches infinity of 3x squared over x squared plus 1, what do I mean? What I mean is, as x gets very, very large, or as x increases without bound, then my function will approach a certain number. Now, if I were to do this with a chart, we can see in this example, as x becomes very, very large or increases without bound in a positive sense, then it seems like this number is approaching 3. We're going to discuss exactly what that means in a bit. Similarly, as x gets very, very large in the negative sense or increases without bound in the negative direction, then in this case, oh my, f also appears to be approaching 3. Now let's look at the definition of a limit at infinity. Let L be a real number. The statement, the limit as x approaches infinity of f of x equals L, means that for every epsilon greater than 0, there exists an m greater than 0 such that f of x minus L is less than epsilon whenever x is greater than m. Okay, let's just use some common sense. Basically, to say that L is the limit means if you get far enough out, for any epsilon you pick, you can find an m so that the functional value minus the limit value is less than epsilon. Another way to think of it is the limit does exist and the limit also equals L. Now let's look at a limit at infinity that you just want to know, and this one kind of should make a lot of sense to you. If R is a positive rational number, turns out it doesn't even have to be rational. Pi works here as well. And C is any real number, then the limit as x goes to infinity of C over x to the R is 0. Now what does this mean? Remember, we can break limits up. This is a limit as x goes to infinity of C divided by the limit as x approaches infinity of x to the R. Well, the numerator is always going to be C. Now what does this become? As this becomes unbounded, this approaches infinity. Now remember, infinity is not a number, but I'm going to treat it like one here. And 1 over a really big number is 0. So I'm just going to put it as x approaches infinity because I don't like that notation. Now furthermore, if x to the R is defined when x is negative, then that limit as x approaches negative infinity is also 0. So basically you put any number, no matter how big, over a really big number and take the limit as that really big number gets even bigger. That limit is 0. So let's look to see how we could use this. What is the limit as x approaches infinity of 5 over 5 minus 2 over x squared? Well, this is the limit as x approaches infinity of 5 minus the limit as x approaches infinity of 2 over x squared. Now, for the first term, it doesn't matter what x is. This limit is 5. And this limit right here is 0. So this limit is 5. So what this means is as x gets very, very large, the function approaches 5 or gets arbitrarily close to 5.